Welcome to Mass Hunter Quant 10.1, featuring target and suspect screening, food safety. Here we go. Let's look at the overall game plan for Quant target suspect screening. Now, the purpose of quantitation, of course, is to analyze target compounds and come up with valid final concentrations. Suspects, that goal is different. I'm there to see if it's there, but I won't end up with a final concentration unless I've got the standard. But I want to do them all in one workflow, and that's what we're going to provide here. So a couple of different dimensions to look at it here. One is we've got the GC-QTOF workflow, which works in the expected way, deconvolution with SureMass and library searching. And that's put into the screener so that we can only see the hits, because when I go through such a long list of targets and suspects, I really want it trimmed down so I only see the hits or maybe the putative suspects to make a determination. Now, the other dimension which I'm going to concentrate in this video is LC-QTOF, and there are several variations of that, including all ions, which is what I'll do the demo here with, and another one, Q-ray, which I'll talk about in a moment as to what's the difference between these. Now, stepping back from what is a target and what is a suspect, a lot of different possible definitions, but one I'll use here is that a target has not only the name and formula, but I've got a retention time because I've got the standard and I can build a real calibration curve from that and come up with final concentrations in the expected usage of Quant. The other suspects, different category, but basically handled the same way in the Quant engine. I've got a name and a formula, and I can derive a lot of information from that. But since I don't have the standard, I can't really know for sure where the retention time is. I might be able to predict it, but I don't know for sure where it is. Now, this is a major difference. I can come up with an estimation here of what amount is present, but these two are handled very similarly in the overall workflow, and that's how we've combined target and suspect screening together. All right, let's take a look at the advantages to target and suspect screening in one application. First, it's simple. As I've said, you can review only the hits against established criteria for both the targets and the suspects. It's also seamless because it's in one application. You can push through to reportings or exporting out to a LIMS from one application. And it is speedy because we're using SureMass. We've converted the profile data, and SureMass is much faster. Some other advantages in the realm of using Quant as the engine is Quant is very targeted in the way it approaches the entire thinking. It has targets, ions it looks for, and qualifiers. Fits very well with the molecular ion, which could be assigned the target, and then looking for conformational fragments, which you could assign the qualifiers. Also, in the all ions workflow, collision energy gives you information about the molecular ion, and then in the higher collision energy voltages, you can see the fragments from that molecule, so you can get a picture of not just the molecular ion, but confirming fragments. Let's take a look at other advantages of doing targets and suspects together simultaneously in the same application, Quant. Well, if you just do the suspects alone, you're going to get the question, where are the QC samples run? Whereas if you do the targets and suspects together, you've got the standards and they are run with the normal quality checks, recovery or quality control samples. You've got that backing when you show your suspect results. You've got the backing in the same process. And I will go through and show you some new tools that make it much simpler to either add more targets or potentially find suspects by the standards and then add them into your target list, and to manage those ions and collision energies as you go through that process. In designing this workflow, we did pay attention to the Santé guidelines. So looking at accurate mass and the QTOF, you can see that you need 2 ions with mass accuracy better than 5 ppm. So that's very likely the molecular ion, which gives you a very strong signal if you're just scanning. And now you can see the need for all ions because we have to get the collision energy increased to see the fragments. So we're going to do all ions at other collision energies so we can match those up and see the fragments to get a confirmation. And last, it mentions in here that there needs to be a correlation, and we do that with the coelution coefficient to make sure that the targets and the qualifiers, as we're going to map these into, do overlap. Thanks for your attention.